Episode 2. This is where it all clicks. Last episode, you installed ComfyUI and generated your first image. And maybe you looked at that canvas full of floating boxes and wires and thought, what does the box labeled KSampler actually do? What's a VAE? Why are there two prompt boxes? Why does everything break when I disconnect that one wire? Episode 2. This is where it all clicks. Welcome back to TGH Learnings. I'm so glad you're here for episode 2 because honestly, this is the episode that separates people who use ComfyUI from people who understand ComfyUI. And understanding it is what gives you the power to build anything, not just follow other people's workflows, but design your own from scratch. Here's what we're doing today. We're going to open up that default workflow that loads when you first launch ComfyUI, and we are going to take it apart, piece by piece, until you know exactly what every single node does, what data goes in, what comes out, and why it's connected the way it is. We'll also do some hands-on modification so you can feel what it's like to actually build with nodes, not just look at them. And if you're coming from any creative background, 3D design, photography, video editing, I've got analogies throughout this episode that will make every concept click immediately. Because the node graph idea is not new, you've probably seen it before without realizing it. So what is a node graph? And why does ComfyUI use one instead of a simple settings panel? Think about any creative software you've used that has a node graph, Blender's shader editor, Unreal Engine's blueprint system, After Effects expression connections, Nuke's compositing graph. Even Excel has this logic. One cell's output feeds another cell's formula. The idea is always the same. Each box does one specific thing, and you connect boxes together to build something more powerful than any single box could do alone. ComfyUI uses the exact same philosophy. Every step of the AI image generation process is a separate node. Text encoding is a node. The sampling step, where the actual image is being created, is a node. Decoding the result into pixels you can see is a node. And they're all connected by wires that carry data from one to the next. If something looks wrong in your output, you can trace the wires backwards and find exactly which node is causing the issue. It's visual debugging, and once you get used to it, you'll wonder how anyone works in a tool that hides all of this from you. Before we look at the whole workflow, let's zoom right into one single node and understand its anatomy. I'm going to use the KSampler, the most important node in any workflow, but everything I tell you here applies to every single node in ComfyUI. Title bar. At the top is the node's name. It tells you what it does at a glance. Yellow-green dots on the left side are the input ports. Data flows into the node here. You can only input one node at a time. Yellow-green dots on the right side is output ports. Data flows out from here and can be connected to multiple input ports. You can only connect one node in the input port and connect multiple nodes in the output port. Next is the parameters at the middle. These are the settings you type or adjust directly on the node. No wire needed. On clicking the node, you will see few more options. By this option, you can change the node color. Different colors indicate different data types. More on this shortly. This is the bypass toggle, which to skip the node without deleting it. This is to convert the selection to subgraph. We will also discuss this later in detail and few more other options. The most important concept to understand is the difference between a port and a parameter. A port is a connection point. It receives or sends data from another node via a wire. A parameter is something you set directly on the node itself, like typing a number or choosing from a drop-down. Think of it this way, a port is a pipe that data flows through from outside. A parameter is a dial or a switch you control directly on the machine. The color of a port tells you what type of data it carries. This is critical. You can only connect ports of the same color to each other. Try to connect two different types and ComfyUI will simply refuse. This is actually very helpful. It's the system telling you these two things are not compatible. Think of it like a USB port. You can't plug a USB-A into a USB-C socket. The shape mismatch is the error. Port colors in ComfyUI work the same way. You don't need to memorize all of those right now. By the end of this episode, you'll have seen them all in context and they'll start to feel natural. You can take a screenshot of this. Let's now walk through every node in the new workflow one by one. Alright, let's trace the data flow from the very beginning. I'm going to go in order, the way data actually travels through this workflow from the first node all the way to the last. Follow along on your own ComfyUI canvas. Double-click on the canvas and search for load checkpoint. Notice that this one node outputs three different things: model, clip, and VAE, all with different colored ports. These three things all live inside your SafeTensor's model file. The load checkpoint node splits them apart so each one can be routed to wherever it's needed in the graph. It's like unpacking a single zip file and distributing its contents to three different departments. Each one gets exactly what it needs and nothing more. Now double-click the canvas and create Clip Text Encode node. The key insight here is that your text doesn't go directly into the image, it gets encoded first. Clip, which stands for Contrastive Language Image Pre-training, is a separate AI model that was trained to understand the relationship between words and visual concepts. When you type golden hour lighting, Clip doesn't just pass the words along, it translates them into a high-dimensional mathematical representation of what that means visually. That encoded meaning is what guides the sampler. This is why prompt engineering matters so much. We'll dedicate a full episode to it. This will be for the positive prompt. We are creating one more clip text encoder for the negative prompt. For now, just know positive is what you want, negative is what you're pushing away from. Now, we are creating the KSampler node. This is the most important node in ComfyUI. The KSampler is where the actual AI image generation happens. It takes the model, both conditioning signals and a blank latent canvas, then runs a diffusion process for however many steps you specify, guided by your prompts to produce a latent image. Before AI creates an image, it actually starts with pure random noise, basically TV static. The diffusion process is the step-by-step method the AI uses to slowly remove that noise until a clear image appears. At every step, the model predicts what should stay and what should disappear, guided by your prompt. So, if you type a futuristic city at sunset, the AI gradually shapes the noise into buildings, lighting, colors, and details that match your description. Think of it like sculpting from chaos. The AI keeps refining the image over and over until the final result emerges. Let me explain the parameters inside the KSampler, because each one has a real effect on your output. Seed is the random number that initializes the generation. Same seed plus same settings equals same image every time. This is how you reproduce or iterate on a result you like. Change just the seed to get a variation. Steps is how many times the sampler refines the image. More steps equals more refined result, but slower generation 20 to 30 is the sweet spot. Beyond 40 rarely gives visible improvement on most models. Classifier free guidance or FFG. How strictly the AI follows your prompt. Low from 1 to 4 gives creative, dreamy, and ignores parts of your prompt. Mid from 7 to 9 gives balanced look, the usual sweet spot. High 12 plus gives very literal, can look oversaturated or unnatural. Sampler is the algorithm used for each diffusion step. Euler, DPM++2M, and DPM++SDE are the most popular. Each has a slightly different character. We'll explore these in episode 3. Scheduler works alongside the sampler to control how aggressively noise is removed at each step. Keras variants are generally smooth and high quality. Normal is the baseline. Denoiser for image-to-image workflows for how much of the original image to preserve. 1.0 is to start from pure noise for full generation. 0.5 is to keep 50% of the input image. For normal text-to-image, leave this at 1.0. Next, we are going to create the empty latent image node, which will be connected to the KSampler latent output port later. This node creates the blank canvas that the KSampler starts painting on. You set width, height, and batch size here. Like opening a new blank canvas in Photoshop or Illustrator and setting the document size before you start. Now, double-click and create VAE Decode node. VAE stands for Variational Autoencoder. The KSampler works entirely in latent space. The VAE Decode node translates that latent representation back into a real pixel image that you can see and save, like converting a raw camera file to JPEG. And lastly, create the Save Image node or Preview Image node. Save Image writes the final decoded image to disk in your output folder with an auto-incremented file name. Preview Image shows it in the canvas without saving permanently. Now that we know what each individual node does, let's connect the full data flow from the very first node to the very last output. This is where the whole picture comes together. The load checkpoint is our fountain. It provides 3 streams of data that flow into the rest of the graph. The model goes directly to the KSampler. The clip goes to both text encode nodes because both the positive and negative prompts need the same encoder to translate them, and then both the clip text encode node goes to KSampler node, and the VAE, the decoder, gets routed forward to the VAE decode node. Separately, the empty latent image creates a blank canvas and sends it to the KSampler as a starting point for generation. The KSampler now has everything it needs: the model, the positive instruction, the negative instruction, and the blank canvas. It runs the diffusion process and outputs a latent, a compressed generated image. That latent travels to the VAE decode, which also receives the VAE decoder from the load checkpoint. Together, they translate the compressed latent back into a full pixel image, and that image travels along the final blue wire to the save image node, which writes it to your output folder. That's the entire pipeline. Every image ComfyUI generates follows this exact sequence. And that's it. You've now built and understood the entire default ComfyUI pipeline from start to finish. You know what every major node does, how the wires carry different types of data, and how the whole generation process flows from a model file all the way to a finished image. At this point, you're no longer just pressing generate, you're actually understanding what the AI is doing behind the scenes. And honestly, this is the moment ComfyUI starts becoming fun instead of intimidating. In the next part, we are going fully hands-on. We'll start modifying the workflow live, adding new nodes, changing resolutions, bypassing nodes for debugging, and learning how to actually build with confidence. So take a quick break, open your ComfyUI canvas, and I'll see you in part 2.